Now today we are going to discuss about dispersions of white light, and we need to first of all understand what white light is. White light is a light that contains all visible color of spectrum with the same wavelength, moving with the same speed. Take note of that last word, moving with the same speed, because they comprises of many colors, but they are moving with the same speed, and it will not look as if it is only one color. But let them enter another medium. We see white light in air medium. If you allow it to enter another medium like glass, so in that case they will have different speed. That is where we are going to see that, oh, they are more than what? One color. So take for instance, if you have number of students queuing, allow number of students to line up, then let them move with the same speed. If they are moving with the speed, looking at them like this, you'll be looking at the first person. You not look as if it is only that first person, but by the time they are now moving with different speed. That's when I discovered that, oh, this is the first person. Look at another person there. Look at another person, because they are moving with different speed. Same thing applicable to the white light. It comprises of many colors, but because they have the same wavelength and they are moving with the same speed in air medium, so we look at them as if it is only one color called white light. By the time you allow it to enter another medium such as glass, you now discover that, oh, it is more than what? One color. That's why we see objects with the color that it can reflect out of the color of white light. Take for instance, if you look at this object, it look what? Yellow. But because it can only reflect yellow color of white light, it absorbs the rest of color. So if you take another object, this one, green, because this one can only reflect only green color out of the colors of white light. Then another one, this is blue. So we see it like blue because it reflects only blue color out of the color of white light. Now look at this one. This is what? Red. You see it red because it reflects only red color out of color of white light. That shows that white light comprises of many colors. But any object we now place under it, we see that object with the color that it can reflect out of the color of spectrum. That's why if you allow that white light to pass through the glass, as you can see it, look at this, you see that because they are now getting to the glass, they will move with different speed. That's why we can see that, oh, it is more than what? One color. You can see the first one is red, followed by what? Orange, followed by yellow, followed by what? Green, then blue, indigo, and violet. So this one shows that a white light contains more than one color. Not only that, when the color enters the glass, they will move with a different speed, and the rate at which they are going to refract inside the glass will be different because they have different speed. You can see the one that refracts least is that of red light because it's one that's having higher speed. But then in the glass, then the one that refracts most is that of what? Violet, because it's one that has the least speed in the glass. Now, what of monochromatic light? Good. When we say monochromatic light, it means the light that contains only one color. So in that case, if you take an object, like let's say the color of that monochromatic light is red, yellow. So if you place this yellow under it, you will see it, because this object is ready to reflect only yellow color. But if you now place this one under, place another color. Let's have another color. This is red. Place it under yellow light. It will look black because this one cannot reflect yellow color. It can only reflect red. When you now place this one under red light, you will see it like red. So you can try that. So when our objects appear with the color that it can reflect. So in that case, we can differentiate between monochromatic light and white light. White light contains many colors, especially we can recognize 7 colors of white light, while monochromatic light contains only 1 color. Then we can see different objects under white light. If you place red there, you will see it because there's red in white light. If you try that for monochromatic light, we can only see the object of that same color. If I have red color, red monochromatic color, and you place red object under it, you will see it. But by the time you place another color, you will not see it. So if you are asked to differentiate between monochromatic light and white light, you can give almost 2 or more differences. For instance, monochromatic light will not disperse. That is, it will not separate. Look at this. You can see the diagram. So it's a monochromatic light. So it passes through the glass without disperse, only refract. So monochromatic light also will refract because it's moving to another medium, but it cannot disperse. But what of white light? White light will first of all disperse and that is separate into its constituents, and apart from that, each color refracts based on its speed in the glass. That is that about difference between monochromatic light and white light. Now the next one is separations of the white light, and I've said it before that we can easily separate the white light into its constituent color by using triangular prism, because they are in the air medium. We see them as a single color. By the time you allow them to enter another medium where they are going to have different speed, we see the constituent of white light. And the separations of constituent white light into its constituent is referred as dispersions of white light. And to do that, like I said, it's very simple. Just allow it to pass through a triangular prism like this. You have your triangular prism like this. So don't forget to draw your normal. So when the ray of light strikes this surface, what will happen is this triangular prism will separate it into its constituent color due to what? Their difference in speed. So the one that will refract least is that of what? Red light. Then you are going to place your screen here on which the screen surface on which the color will appear. So this one will appear here as red. Then the one that will refract most is that of violet, and you see it around this place like this. It will appear here. So in between the red and what? Violet, we have other 5 colors like orange, yellow, green, blue, and what? Indigo. So this is the first one, that is red light and what? Violet. Now that is that about how to separate white light into its constituent. And mind you, this kind of separation cannot give you what? Clear color, because the color what? Overlapping. Before the end of red, you'll be seeing what? Orange. Before the end of orange, we'll be seeing what? Yellow. That's why we call it what? Impure spectrum. Impure spectrums of white light. Then how can you now make it what? Pure. So you need 2 convergent lenses. You place one here. Around this place, we place another one before the screen now. So we place another one around this place. As you can see, look at this diagram now. You can see that it comprises of 2 lenses. So that at the end of the day, you will see on the screen, you will now see clearly red, orange. So you see red clearly before orange, orange clearly before yellow, and that kind of separation is called pure spectrum. So when you use only one triangular prism, what you are going to get is what? Impure spectrum. So that is different between impure spectrum and pure spectrum. Though they are going to separate it, but in case of impure, the color will what? Overlap. Now, the next one is recombinations of what? White light. Recombinations of white light. When we want to recombine the colors together, so at the end of the day, you've separated it. You want to recombine. When you combine all the colors of white light again, you will still get what? White light. For instance, the first thing, you place your triangular prism like this. So this prism, we separate it. In order to recombine it together, you now reverse another prism here like this. So this one we separate it, and this one will recombine. At the end of the day, on the screen here, you are going to see white light again. And look at this diagram now. So in this case now, you are going to see the result at the end of the separation is what? White light. And that's what we call the combinations of white light. So this will be the end of today's topic. And please don't forget to like, share, and subscribe. Then, if you want to join us on our weekend class, so you can still contact me through my phone number or text message through WhatsApp. So the class is Science Master Academy every weekend. Not only physics alone, we are doing chemistry as well. So I have other experts in chemistry that we are together carrying out the activity every weekend.